Hi everyone, this is Yijun Wang. Today we're going to talking about the NAND operators. So before we're talking about NAND operators, let's first take a look at the NAND gate. So what do you think the NAND gate means? We have AND and N in front of. So just pause for 1 second and think about it. I think everybody figured out the answer. It is the opposite of an AND gate. So before we're taking a look at the NAND gate truth table, let's first take a look at the NAND symbol means. So this is what the NAND symbol looks like in the physics world. This is two switches. That also means the input in the IT set. We also got a light bulb. That means also the output in the IT set. And this is what the NAND gate truth table looks like. Under the switch 1, there's 1 and 0, and light bulb 0 and 1. So if the switch 1 is 1, that means switch 1 is on. If the switch 1 is 0, that means switch 1 is off. When the light bulb is 0, that means the light bulb is light on. When the light bulb is 1, it means the light bulb is light off. And we also got a logic symbol there. And this is what the NAND versus AND gate truth table look at. Let's first take a look at the first line of this truth table. When both switches is on, under the AND gate, the light bulb should be on. But on the opposite, the NAND gate, the light bulb is light off. And let's take a look at the north line. When both switches are off, the light bulb is off. When both switches is off, under the NAND gate, the light bulb is on. And when either switches is on, that means 0, 1 or 1, 0, the light bulb should be light off. But on the other side, the NAND gate is also opposite. So what we can get from this truth table, we can get the NAND gate, the output of the NAND gate is opposite of the output of an AND gate. And NAND gate is also called universal gate. So any other gates such as OR and NOT can use NAND gate to represent it. So let's start by learning how to use NAND gate to represent it. This also helps reduce cost and size of the devices in physics world. First start with a NOT gate. Let's look at the truth table first. When both switches is on and when both switches are off, the light bulb is either off or on. So we have the kind of a rule there. When both inputs are at the same logic level, we can connect them connect together at a particular level, and we come back there. So when both switches is 1, we can combine them into 1. When both switches is 0, we can combine them into 0. So that is connect 1, 0, 0, 1. So the output is inverted. So just look at the property of the NOT gate. So just a single NAND can perform the same operation as the NOT gate. And then we take a look at how to use the NAND gate to represent the AND gate. So NAND gate and AND gate are a complement with each other. So if we put a NAND in front of the NAND gate, we get two negatives. NOT and NOT. Two negative become positive. So what we can get, we get using two NAND gates can give us an AND gate. And lastly, how we can connect OR gate with the AND gate. So before we're talking about it, let's first apply for the De Morgan symbol. So De Morgan symbol says A NAND B equals NOT A plus NOT B. And we also know that A or B equals A plus B. So that is also means under the NOT A, we just figure out. So NOT A equals NAND AA plus NOT B equals NOT NAND BB. And NAND AA plus NAND BB is also means NAND AA and NAND BB. We can also put a NAND in front of that. NAND, parenthesis, NAND AA and NAND BB. We can also get is NAND is equal to A plus B. That is exactly what is A or B look like. So only that in case the inputs are inverted. What we can get from this formula, we can get using 3 NAND gates to get the OR gate. So after we learned that, let's just do a problem 1. You can just pause the video and do it by yourself and then continue the video later on. I'm just going to continue that. So A or B, we just figure out using 3 NAND gates to represent A or B. So that is what we look at. And NOT A, it means using 1 NAND gate to represent the NOT A. This is what NOT A look at. And we also got NAND in the middle of that. So just put that in front of it. I hope everyone just enjoying this short video to give you the brief introduction of what the NAND gate means and how you can use the NAND gate to represent NOT or an AND gate. And appreciate you listening today and thank you for coming today. Thank you.